Good morning, students. The next problem, once again from instrumentation paper, engineering paper. In the circuit shown below, a step input voltage of 5 volts magnitude is applied at node A at time t equal to 0. If the capacitor has no charge for t less than or equal to 0, the voltage at node B means the voltage across the capacitor. What is the voltage at node B, or what is the voltage at the capacitor plates at t equal to 6 microsecond? Now first of all, you identify this problem belonging to the chapter DC transients. DC transients. If you want specifically, it is DC transients coming under RC circuit. To go further, it is charging of capacitor. It is on charging of capacitor. Now students must know what is charging of capacitor in a circuit. Now if a capacitor is connected through a resistor to a source of voltage, the capacitor is going to acquire voltage from the supply and charging takes place. Larger the resistance, longer is the time taken by the capacitor to acquire V volts. Ultimately, C will acquire V volts. Then current in the circuit stops. So charging current will be like this. This is charging current. So it falls from V by R to 0 in time t equal to infinity. You have studied this in initial conditions because charging current has to cease. Now capacitor acquires voltage like this. Exponentially, and it is going to acquire a voltage V in time t. In time t equal to infinity. Theoretically, in infinite time, it is going to acquire V volts. So, and student must know the equation for capacitor voltage. Now, in the gate examination, you will not have time to derive. You have to compulsorily you have to remember few equation. One such equation in this problem is, in this situation, the voltage across the capacitor is given by V into 1 minus e to the power of minus t by RC. V is ultimate voltage. T means time t in seconds. R means net resistance in the system. C means net capacitance in the system. Okay. So Vc of t is equal to V into 1 minus e to the power of minus t by RC. I will make use of this equation in this problem. Now, in this problem, there is a mention about step voltage. So what is step voltage? A step voltage will act for t greater than or equal to 0 and the voltage remains constant at 5 volts. So it is equivalent to, now I will modify this circuit diagram. It is equivalent to a 5 volt source. Which acts for time t greater than or equal to 0. For t less than 0, its value is 0. That is why step is mentioned. Now, a step voltage is equivalent to 5 volt source. 2 kilo ohms, then capacitor, 5 nanofarad. Then this is node B. We have to find capacitor 5 nanofarad, then resistance of 3K. Now, in this first, there are two resistors, whereas in the circuit I took, there was only one resistor. Therefore, we have to modify this circuit based on source transformation. So, we have studied what is known as source transformation. A 5 volt source in series with 2 kilo ohms is converted to a current source a current source 5 divided by 2, that is 2.5 milliamps in parallel with 2 kilo ohms. Next is capacitor remains here and then 3K. 3K, 2K, they are in parallel. Therefore, equivalent resistance is 3 into 2 divided by 3 plus 2. That is 1.2 kilo ohms. That is 1.2 kilo ohms. Now, I will combine 3 with 2K and I will make it 1.2K. Now reconvert a current source in parallel with 1.2 kilo ohms into a voltage source in series with a resistance. So 2.5 into 1.2, that is 3 volts. So 3 volts in series with 1.2 kilo ohms. 3 volts in series with 1.2 kilo ohms. Then capacitor is connected here. 5 nanofarad. Now you write the equation. As Vc of t is equal to 1 V into 1 minus e power minus t by R equivalent into C. Now V is 3 volts. We have to find Vc at the end of 6 microseconds. 6 microseconds. 3 into 1 minus e power minus 6 microseconds. 6 into 10 to the power of minus 6 divided by R equivalent. R equivalent is 1.2K into C, that is 5 nanofarad. 5 nanofarad equals 3 into 1 minus e power 10 to the power of 3, 10 to the power of minus 9, 10 to the power of minus 6. Going to the numerator means cancels. Next, minus 6 by 1.2 into 5, again 6, that is 3 into 1 minus e power minus 1, that is 3 into 1 minus 1 by e. Calculate. Roughly E is equal to 2.7. Therefore, answer is 3 into 2.7 minus 1 divided by 2.7 equals 3 into 1.7 by 2.7 equals 3 into 1.7 divided by 2.7 equals 1.8 volts. So at the end of 6 microseconds, the voltage on the capacitor plates is 1.8 volts. So this is the answer. This is how you have to work out the problem. Thank you.